The topic of our group is image denoise software design. We divide it into 5 parts, just shown in the PPT. With the rapid development of computer science and image process technology, images have been widely used in medical imaging and pattern recognition. However, in the process of image formation and transmission, it will inevitably be disturbed by noise. The noise in the image is often intertwined with the signal, which will make the details of the image, such as border contours, lines, and so on, become blurred. There are many reasons for noise, and there are many types of noise. Therefore, it is necessary to reduce the noise of the image to facilitate higher-level image analysis and understanding. In this project, we designed an image denoising software based on MATLAB GUI development platform for image denoising, which is more efficient and faster, including mean filtering, media filtering, notch filtering, Gaussian low-pass filtering, Butterworth bandpass filtering, and Butterworth band reject filtering methods. And we used these 6 methods. Next, let's introduce these methods in this project. Mean filtering is a type linear filtering method. It refers to giving a template to target pixels on the image. The template includes neighborhood pieces around it, and then the average value of all pixels in the template is used to replace the original pixel's value. As for the sort and paper noise, we can use media filtering to reduce it. Add a matrix of the template size from the image each time. In addition, sort all elements and the media value is placed by the center of the board. Then restore to the original image, and so on to scan the entered image. The principle used in the method is shown in the PPT. If there are some interference in the images, for example, the vertical axis reverses a series of small bursts of energy near the origin, which correspond to the nearly sinusoid interference. A simple approach is to use a notch filter starting with the noticed frequency burst and extending for the remainder of the vertical axis. The transfer function is shown here. Gaussian filtering is a linear smoothing filter, which is a process of weighted averaging of the entered image. For the other 2 methods, bandpass and bandreject filter transfer function in the frequency domain can be constructed by combining low-pass and high-pass filter transfer functions, with the latter also being derivable from low-pass functions. Now let's introduce about the GUI interface. First of all, the upper right corner of the interface is the control area, which can select the image that the user needs to process. In addition, when clicking the faster denoising button, the user can deal the image with median and mean filtering. And the clear button can clean textbooks data and chart data. Secondly, the lower right corner is the function selection area. According to the different types of image noise, users can choose different process methods and can output some parameters required by the methods. Finally, when the Unicode denotation button is processed, the result of image denotation will appear in the result display area on the left. Next is the display of the result using the GUI. Mean filtering has fast speed, simple autograph, and can smooth the image, but the noise reduction effect is poor. Media filtering is a common used nonlinear filtering method, and it is also the most commonly used preparation technique in image processing technology. It is very effective in smoothing impulse noise. In low-pass filtering, the discrete Fourier transform has a relatively good noise reduction effect on the image. At the same time, the introduction of the faster Fourier transform solves the problem of too much calculation and no operation time required for the discrete Fourier transform. The filter can deal with the predictable noise, and the user can remove the noise at the specified position in the frequency domain by changing the parameters so that the image can be more accurately denoised. Using this filter can achieve better results. This is the notch filtering result. Figures shows an image of part of the ring surrounding the plant center. This image was captured by Cassini. The linear sinusoid pattern visible in the image is caused by a AC signal superimposed on the camera video signal just prior to digitizing the image. This was an unexpected problem that corrupted some images from the mission. Fortunately, this type of the interference is fairly easy to correct by post-processing. One approach is to use notch filter. The finally is conclusions. There are two conclusions. The first is the design of the GUI interface can help user complete image denotation more efficiently and quickly. For different types of noise, user can choose different methods to achieve the best image denotation effect. The second one is when selecting some methods, the user can also set parameters through the GUI interface to achieve the best denotation effect. This is our timeline and the Gantt chart. This is our reference. That's all. Thanks for listening.